Traditional AI conversations are stateless. Every interaction requires you to repeat context, preferences, and background information that you have to pass each and every time you run an AI agent or an LLM. So in this video, you'll learn how you can leverage memory to be able to maintain the context across a single session or across multiple sessions with the help of an open source project called as Gibson Memory inside of an AWS framework called as Strands SDK, that is an official AI agent framework from AWS. So first, if you're already not aware, so we have Strands Agents SDK. This is an official production-ready multi-agent AI system SDK provided by AWS. It's also open source, and you can check it out on GitHub. We have the Python SDK available, and you can find a bunch of different user guides on GitHub as well. And then for our memory layer, we are going to be using Gibson Memory, which is a SQL native memory engine, which means that by choosing whatever backend that you want, whether it's SQLite or maybe something like SQL, you can actually store all of the different conversations that you have with your system or any other important metadata inside of your SQL layer. And then you can repurpose that during the conversations that you're having or during the runs that you're making with the AI agents, that the AI agent can maintain context of previous messages in the same session, or maybe you could also use it as a long-term memory agent as well, where you could derive preferences of the user and make more personalized AI agents. So a classic example to understand this diagrammatically would be of how basically things work is that as soon as the user inputs a prompt to, let's say, the Strands Agents SDK, at that time with memory or the Gibson memory, will be able to save those memories inside of this external SQL, or in this case SQLite database. And then next time when the user asks an input prompt, now they'll basically not just be interacting with the agent, but they will also be able to access the saved memories. So this will give much more personalized responses to the user. So this example could be that, let's say that you're trying to build a professional development coach agent and where the idea is that this agent can keep track of your career goals and also progress, or the progress of that you're making for your goals, and can monitor them, and you can ask it, and you could have a multi-session conversation continuity where the agent still remembers that what was your career goal and how long have you made the progress. So rather than having to forget each and every time, you can persist that. So let's first understand what's going on behind the scenes, right? First, let's try to run the example, and then we'll do a quick code walkthrough. So I'll just run the example here. So in this case, you can see that these are all of the different available features. So first we can say that help me set a career goal to become a C++ programmer. And then it says that let's set a clear goal. In the meantime, it has saved this to the memory, and then it also needs to have the target date. So we'll say the target date is December 2025 and priority is high. And we have set this, and then I can ask it, what is my career goal? And you can see here that it says that the career goal is to become a proficient C++ programmer. And the reason that it's having is that as soon as I provided my preferences to the agent while interacting with the agent, we saved those preferences in Gibson memory. And then when now the user asks a follow-up question inside of the same session or across a new session, it'll be able to, when the user asks the intent of the user, we'll check if there is anything in the memory which might be relevant to the user. And then we'll be able to append some of the metadata or a response from the memory and append the response or augment the response of the LLM inside the AI agent to make even more personalized responses. So that is a quick overview of how things work. Now let's quickly go over into the code base and explore what's happening. So first of all, what we're going to be doing is that we're going to be using Memory SDK. We'll be installing that package. So this is the official memory from Gibson. Then we have Strands Agents, and then we're using Lite LLM so that we can use NebACI models. So if you're already not aware, NebACI provides you a bunch of different open source large language models that you can use. So initially we go ahead and we import all of our different packages, and then we start to define our demo coaching session. So here are some functions that you can use to understand what all functionalities that are there. So here we are importing our Strands SDK and the model, which is going to be a Lite LLM. And then we import memory, and we also import the create memory tool. So this is the tool that allows us to create those memories and store them into our database. So next thing that we do is that we have just defined some data classes for skill, for career goal, because we have a bunch of different things where we can set a career goal. So in this case, you can see that when we are setting a career goal, it requires the goal, the target date, and the priority. And then what we do is that because when the user is setting up a career goal, we also save that into the memory. So we use memory content is equal to this, and then we would use this to further save it into our memory for future reference. Similarly, we also have additional functions to assess the skill of the user and also track the learning progress that the user has made. Again, in this case, we have just the different types of use cases, and then for all of them, we are essentially now storing the memory content. And similarly, we also have another function for recommendations. So The next thing that we're doing is we are initializing our memory system. So in this case, we first define where exactly are we going to store our memory. So in this case, we'll be creating a new SQLite database called professional codes memory. And we also initialize OpenAI. And then we finally initialize our memory with the connection to the database. We provided a namespace as well. And we go ahead and save. Once you have enabled memory, we'll be able to save all of the memories that we have been capturing from all of the prior functions which have been defined over here, where, for example, you can see that the memory content, all of this is going to be stored inside of the memory. So then finally, we go ahead and create our agent itself. So we define all of our different tools. We also create the memory tool. And then we have a function which is going to have a memory search wrapper for the agent, where based on the user's question, we will search in the memory if there's something specific. For example, if a question is related to career goals, then we'll be able to search for that in the career goal. And finally, we are wrapping it all the tools over here. So we have the search memory, and then we have the dedicated tools over here, which are related to all of the different functionalities that we have. We also define our model. So in this case, we are using an AWS 23 model. And finally, we define our agent, where we pass our model. We pass all of the different tools, including the search memory tool, so that can proactively search for all those different memories. And finally, we go ahead and create our main function, where we first initialize our memory system. We create our coaching agent, and then internally it automatically takes care of like handling all of your conversations for you. So now what we're doing is that here we just start with our conversation count, and we record the conversations inside of our memory for future sessions, so that you could also ask questions related to, okay, what was my previous conversation? And then we just keep a track of how many conversations you have done so far. And this way, like, the user can ask any questions related to, even if you're starting a new session, we just know that, okay, like, there's a new conversation started, and we'll be able to persist that over here. So this way you can basically add a memory layer to your agents to make them more productive. You don't have to basically like lose context across multiple sessions, because this allows you to make much more personalized agents. So that's a quick overview of how you can add memory to your AWS Strands SDK with the help of Memory by Gibson.